Hello, my name is Trace Bannon. Today, I want to talk to you a little bit about no hobbyists. It's really a conversation about how we help to shift cybersecurity left. A little bit about me. Who am I? Well, Trace Bannon. My full name is Tracy. I'm a senior principal with the MITRE Corporation. I live my life as a software architect, as an engineer, and I focus on solving problems with software. The company I work with, MITRE, is a federally funded research and development corporation in the United States. We were chartered by Congress to really be there for the US government to provide technical leadership and guidance. You know, in the course of today's conversation, there are going to be a lot of opportunities to deep dive, but we're going to keep it at a cursory level. And I've provided links and other resources for you to dive a little bit deeper. So check this out. This is from about the March timeframe. I didn't even bother to update it because all these things just keep happening day in and day out. These are typical headlines, Look at this. GitLab addresses critical account hijack bug, NVIDIA. We know about all of these, and what it's causing us to do is it's causing us to really call out to try and shift security to the left. We say, quick, shift left. What is that? What's that mean though? How do I shift security left? Well, it means that your security activities actually need to start at design. It's not something that is bolted on later on. It extends through the entire SDLC, software development lifecycle, from vision through fielded operations, and then there's continuous feedback at every loop. First it was shifting ops to the left, and then we had an infinity loop, and now we're shifting testing as well as security. Do you see a trend? The trend is shift left. Now, I actually don't advocate just shifting left, especially when it comes to security. Instead of shifting left, let's shift security everywhere. Let's make cybersecurity ubiquitous. It is absolutely everybody's responsibility. Now, when you are shifting, you need to address these four facets. And I've run into multiple situations where people address one, but not all of it. Usually they focus on process and technology. But let's talk about this. You're shifting to the left. That is, you're shifting ubiquitously. You're shifting until the first possible time that you can start something needs to begin with talking to people. What are their roles? What autonomy do they need? The decisions that they can make. Is there an upskilling need? Processes are the workflows, the ceremonies. Some things may be domain specific. Technology, well, look at how you're going to insert new technology. Look at digital platforms, understand your production environment. And culture, people, process, tech, and culture. Trustworthiness, psychological safety, collaboration, they are all elements and aspects. They are facets that you need to address if you're going to shift. This all sounds logical, right? Sure does. How do you do this? How do you really do it? Well, I always start at the beginning. Begin by building new culture. I don't usually say change culture. I talk about building culture. And together, as an organization, you need to define what your unifying principles are. Agree on the roles, on the responsibilities. You also want to define your security software development framework. This is often called the SSDF. It's been defined in the US by a group called NIST that sets standards. It tells you what to do, not necessarily how to do it, but we'll dive deeper in a moment. Now, another way to help to build a culture, to build trust, is to work elbow to elbow and demonstrate the model behaviors that you want to see in one another. Culture is the core of a strong cybersecurity basis. So let's talk about that secure software development framework. You don't want to start from scratch. There are industry standards. You can see the pub that's listed here, the 800-218. Now, it'll tell you what to do. You are going to define how you're going to do it. But here are a couple examples of the things that are included when you're defining your secure software development framework. Again, you're not just shifting left. You're looking holistically at all the things that you do to make a better cyber resilient product. Provide adequate software security training, agree on your development lifecycle, establish some secure coding standards, and look at using and rebuilding, or I'm sorry, building and leveraging reusable objects. If you build it once, make sure that it is cyber intense. Then you can leverage it again and again, and also verify all your security controls. I'm going to jump forward and I'm going to talk about threat modeling. What you're seeing is a part of the threat modeling manifesto. Why do you threat model? Well, people together need to recognize the design and implementation challenges that need mitigation. Who should threat model? Everybody, the entire organization. But what does this have to do with cybersecurity and shifting ubiquitously? Well, you can turn it into a team sport. So make threat modeling a team sport. And generally, you'll follow this kind of a 4-question framework. You're going to ask, what are we working on? What's the feature? What's the capability? What could go wrong? What are we going to do about it? And then after the fact, after we've mitigated it, did we do a good job? Asking whether or not we've accomplished what we set out to do. Now, when you want to make this into a team sport, I actually advocate starting out small and bringing people together and using existing user stories as a way. Again, we're trying to build the capabilities of the entire organization, expose them so that they have a security mindset, and build culture together. So let's do that by capturing some threat information in plain language. I like to use the user story Mad Lib. We're all familiar with as an X, as a user, I want to do something so that I can accomplish my outcome. Now, we add 2 additional pieces to that. We add something that the end user or the as a, something that the user would like to protect and what they want to protect it from. So we capture that in plain English. So the business can come together with the development team and delivery team, with the operations folks, with security, with others in the organization, and they can actually rally around this and get to know the capabilities and get to know the exposure points of others. Let's look at an example. So this assumes that we're working on an autonomous car. Maybe we got a job with Tesla, and we sit down and we talk about adding a critical asset and the possible threat. So as a car driver, I want to enter a destination name so that I can navigate without an actual address. Maybe I say the name of the local mall, the Capital City Mall. I would like to travel to the Capital City Mall. And I want you as a user, I want you as the driver to protect my search history. That's the critical asset from being accessed by others. So that's the threat. So critical asset and the threat get added to your user story Mad Lib. Again, the point of this is to help the entire organization become cyber thoughtful in all that they do. So is it time to code yet? Not quite yet. And remember, I'm coming at this from a developer, a delivery team, an architect, and engineering vantage point. And what do I do to help those delivery teams? What's happening right now is that more responsibility is being placed on the developers. There's a constant addition of new tools. The training that folks get, if they get it, lacks depth. And there's a lot of pressure right now to go fast, go fast, go fast. And a lot of times we have to experiment on our own time. We're reading on our own time, if at all. It's not acceptable. That's what I call a security hobbyist. I love the quote that's at the bottom of this. It says, developers are not experts in waving a magic wand to cast spells to defend against the evil hackers in the black hoodies. Now, there's some truth to this, because developers by nature are builders. We need to help them to not be hobbyists. There are many things that we need to do to help shift the security responsibility everywhere and to make sure that the development and delivery team is up to the challenge. So how do we go from being those hobbyists, no hobbyists, how do we go from being a hobbyist to a pro? How do we enable and protect the developers? Well, training and education. Make sure that you're secure by design. Use coding standards, secure coding standards, leverage design patterns. You really want to encourage experimentation and double down on different types of tools to reduce noise and cognitive overload. Help people to stay focused. Let's quickly run through these and dive into each one. So upskilling and training developers, I use the 70-20-10 model. What it means is that only 10% of training should be classroom training. Go from that reading and that formal training of the book learning, and then branch out into the social and informal. These are the communities of practice. These are the brown bags. These are events, the hackathons that you experiment with and experience together. 70% of your learning, of the learning of those people that you are enabling, needs to be experimental, experiential, needs to be on the job. So 10% formal, 20% social and informal, 70% actually do what you've learned. So what are some non-classroom training examples? You could run a hackathon. I like to use the OWASP projects like Juice Shop or WebGoat. You could enter a competition. The firm I work with, MITRE, has an open cyber academy. You could pair a program using SAST tools, and we'll talk about that a little bit later, but those are your static application security testing. You can pair up and do that together, or storm the castle. Again, there are many fun things that you can do. Sometimes it can feel like a little bit of a stretch, but bring people together in a non-classroom setting, allow them to have that social experience with one another, setting them up to be able to accomplish the on-the-job work. Is it time to code yet? Not quite yet. I always take people back to design. Design is the guiding principle. It is how the system will be built. From the code to the architecture, we really need to be intentional about secure by design. And it does mean that you'd have to have active decision-making and annotation of what those decisions are. Not everybody does this. Some folks believe that you make the decision at the spur of the moment or at the time of coding. We need to step back a little bit, go a little further back in the SDLC, in the development lifecycle, and make sure that we're addressing them. So before you code, be secure by design. It's a concern. It's not a feature. That means everybody needs to have it as a concern. It needs to be top of mind. It cannot be a single feature, a requirement, etc. And always be thinking explicitly about security. Your context and the architecture type, the archetype actually matter, because different types of domains, different business areas, different industries do have different contextual security concerns and may already have bodies of knowledge that you can harvest immediately. Focus on that domain as well. As I said, many security bugs are caught implicitly in your domain. There are many coding standards. There may be additional libraries, additional checks, additional scans that you can run pursuant to your domain. Secure coding practices are so important. Look at this, 82% of software vulnerabilities are from coding errors. So make sure that you sit as an organization, again, together as a collaborative organization, agree on what your secure coding standards are for your team. Make sure everybody knows the standard. Run SAST security tools, and then developers make sure that they have the ability to run that before code complete. Don't make developers wait until they are inserting into the database, inserting into the code repository. Allow them to run those things themselves to get a feel for whether they're going to pass. I just want to show you there are a number of different secure coding standards, and there are many secure coding practices that fall within that. You can dive deeper with this with your teams. So is it time to code yet? Almost. Dedicate some time to figuring out your dependencies. I'm surprised how many organizations don't do this, do not know their dependencies. document your package and program dependencies, and then align to the stream of your SSDF. So you need to know your secure development framework, and then you need to understand how your different dependencies map against that. And are there cross dependencies within your organization? Run a composition analysis tool, a SCA, and look at SBOM. This is a growing, changing area. Keep your finger on the pulse of this. You want to be able to look at your software bill of materials. That's really the listing of all of the capabilities, all of the softwares, all of the open source that are in the software that you are building or that you're consuming. There can be tiers of SBOMs. Dedicate time to knowing those dependencies. Then learn to break things. That's right. Developers, architects, engineers by nature, we're builders. We're not breakers. Quality engineers, testing organizations, security, they are breakers by nature. We need to help folks who are builders to learn to break things, not because we want them to hurt things, but because we want them to have that frame of mind, because they will build more secure software. Learn to love application security testing. I know I do. It's actually really fun. These are a couple of ideas for the different types of AST security testing, application security testing. You can have the earliest detection is with static scanning. It's that static AppSec testing. There is, before you go into production, if you want to have an outside perspective, you can use a DAST tool, Dynamic AppSec. And then there are other flavors of this using agent-based and, again, software composition analysis. You know, there's simply too much code being produced right now, too much for a human to handle. So we need to start to look at other tools that will help us reduce the noise, but will improve our security posture. Here are a couple of tools. These are just a few that are available right now, a tiny sample. You'll see OWASP, Threat Dragon. You'll see on the right hand something called White Source Cure. HashiCorp has a secrets manager, secrets detection by GitGuardian. Again, the most important thing here is leveraging tools to help you to deduce, to understand where issues are, providing those tools to your organization. It doesn't mean only settling on one tool. It means finding those tools that help your organization to reduce the security risk and posture. So everybody has a responsibility for security. So everybody needs to be equipped. Again, I know I keep harping on it, but let's help the developers. Let's help the delivery teams. Security folks know how to do their security stuff. Let's help the delivery teams. Let's help the designers. Let's help everybody to make sure that we are secure by nature, secure within the very fiber of what we are building. So now let's code. So again, my name is Tracy Bannon. I go by Trace. You see two email addresses here. My MITRE formal address at business, but I answer emails in my free time. Do reach out to me on LinkedIn or through Twitter. I am so glad to have spent some time with you today. Thank you.